Hello and welcome, my name's Jordan and today I'm going to be teaching you how to make a destructible tile map. Tile map. If you're anything like me, then you've probably been scouring the internet trying to just get your head around this, or this might even be the first video that you've clicked on. Hopefully so. It'll save you a lot of headache, believe me. So the task of this is to take a tile map, split it into multiple sections and kind of do whatever you like with it. In this case, we're going to be adding some physics, and then they actually start moving around and interact with each other and the world. And to do that, we're going to be looking at making 5 different scripts, which I may be able to shorten down to 4, but we'll see how we go. We're going to be using 4 different prefabs, a single tile map for the destruction. Of course, you will still need a tile map for the rest of the game, but this modular system will only require 1 set of tile maps separately, which is really good because then it means it's not going to get involved with anything else that you don't want it to destruct. And the tile set that I'm actually using is a Splunky inspired tile set, which I picked up from Open Game Art. So I'll leave a link in the description below if you want to go ahead and pick that up as well. So I'm just going to quickly show you how this works. Of course, this is without anything else, no other interactions of a game, but it's very modular and it'll be easy to implement, and we will actually do that in the final episode. Or I say final episode, I don't know if it's going to be a series, it might just be 1 episode, but yeah, at the end of it we'll have a look at integrating it into a game. So quite simply, in order for any of these to break apart, a impact spot must spawn. So I've just set these up to keys on my keyboard, or numbers on my keyboard. So when I press number 1, these wall tiles are going to explode off to the side. Now the reason being is because the impact spot is just here to the right. However, depending on where the impact spot is relative to the actual tiles, changes on how you can destruct it. You can also change the width and the depth, just in case you don't want to go for a 3x3, or you want to be able to turn it into like an upgradable weapon or something like that. So let's go ahead and show you the action. And as you can see, the tiles are actually being broken apart and interacting with the world. So let's go ahead and open up a new project. If you head into the Unity hub, now just for reference, I will be using the 2021.3.9f1 editor version. It's completely up to you which one you use, although it's possible there may be some changes. But the code itself should remain the same. I don't see any reason why this wouldn't work in a later version. So yeah, so let's go ahead and open up a new project. Now, of course, because we are going to be using tile maps, we do need 2D. However, you can make a 2D, 3D, or even using the URP system, and this will still work the exact same. But for now, just to keep it simple, we're going to open this up into a 2D. If you do decide to go for 3D, just make sure to go to the package manager. At the top, you go Windows or Window Package Manager. And then you can install the 2D file sets separately. So let's go ahead and just name the project. Let's call it Destructible Wallow ? Is that how you... Oh, can't do a question mark. Is that how you'd spell Wallow, I guess? So let's go ahead and create a new project and give it time to load up. So let's go ahead and get this going. Obviously it's a lot easier said than done, and I do have my own default layout just here, but of course you'll be absolutely fine if your Unity doesn't look like this. To get started, as I said, we're going to need 5 scripts, so let me just check my notes real quick. Okay, so let's go ahead and make those scripts now. So I'm just going to right click, create a C# script, and we're going to be calling this first one destroy on empty. This one is just a tiny script that isn't actually going to do a lot. but you'll understand why we need it later. The next script that we're going to need is a destruction source handler, which is going to be basically converting the tiles from the impact point. It's going to be getting the actual tiles that are going to be interacted with from the impact point. And then we're going to want another script, which will be called destruction visual handler. And then again another script, which is going to be the fade out handler. If I can spell. And then one more script for the sprite updater. Sprite, not script, sprite updater. So from there, let's just open up our scene properly. So we're going to right click in our hierarchy, go to 2D object, go to tile map and rectangular, and that will just give us a basic tile map. I'm going to call this destruction tile map. And then for the rest of our map building, let's go ahead and create another one. So we can actually just duplicate this. If you click on it and do Control D to duplicate and rename this up here. So let's just call this base tile map. And I'm just going to move that above. It doesn't make a difference. I just think it looks nicer when it goes down like that rather than underneath. I don't know why, but personal preference. So then from there, now we have our 5 scripts, our tile map ready. So let's go ahead and make an impact point. So to do that, I'm going to right click, create empty game object, and just name this impact point. And then on there, we are going to be adding the destruction source handler. So let's go ahead and just drag that script over and add component. Now we don't need anything else on there, so let's go ahead and open up the destruction handler. Okay, and there we are. So let's get rid of all of this because we're not going to be using it for the moment. We can leave it as mono behavior, but let's get some variables in that we'll be using. So first of all, we'll be using a timer. Just because I like to have this available if for whatever reason you don't want this to happen constantly, and you would like this to happen over time maybe, then I'm gonna have this set up so then you can actually choose to do that. Again, I like to make it modular, so obviously every option is worth having, and it's always good to future proof just in case, especially if you're going to be using this in a different project. So we're going to need a timer real quick. So public int update timer, public int max time, and then we're going to need an offset for the start position, public vector 2 offset. And the reason we're going to need that is because if we head back into Unity quick and I zoom in, you'll see these squares. So the tile map starts from this corner, I believe. It's either the top left or the bottom left. But if our impact zone or impact point is somewhere other than one of these corners, then we need to be able to adjust for that. And if our impact point is here, but our tile is here, it's not going to be able to detect it. So we need the offset in order to move from this tile space to this one to make sure that we're actually affecting the right tiles. And from there we will also need a default radius, which will be the width and depth that we're actually going to be breaking down the walls. So this doesn't need to be public, so let's make it serialized. Private vector2, and we're going to make this an int because we're not going to be using half numbers. We're always going to be using full numbers. So not 1.1, 1.2, but 1, 2, 3. And we'll go ahead and call that the default radius. Because of course, if you do want to change it, or you do want to make this a public variable, that's completely up to you. If you don't know what that means as a difference, a public variable can be changed by another script, a private can't. So once we got that, we're only going to need a couple more things, which will be our tile map. So let's go ahead and make that serialized again. Private tile map. And if for whatever reason it doesn't add this line up here for you, just go ahead and type that out. It's using Unity engine.tilemaps. Without that, it just might not come up with tile map at all. You may not even be able to access it. So this will be our destruct. Now I'm going to spell this with an I. Destructible. No, let's go A. Is it an A? Right, I'm going to have to Google this now. Oh, of course it's an A. It's an I, so I was correct. Let's go. Destructible tile map. And then last one, private game object. And this will be the tile splitter prefab. So we'll get into the tile splitter later on, but for the moment let's get our source handler done. So to get started, let's make a start function. And in case you don't already have this in your project, I'm going to add this in here, and you can remove it if you like, but this is just going to cap our game or our scene to 60 FPS, and you can do that with quality settings.vsync because it has to be enabled in the first place to use, and then you can do application.target frame rate equals 60 for 60 FPS. And just in case we forget to add our destructible tile map, or for whatever reason it's not connected, let's add that just here, so then we can pull that from the game. So if destructible tile map equals null, so if it's not connected, destructible tile map equals game object dot find destructible tile map dot get component tile map. And I'm just going to go ahead and make sure that this is what it's actually called in the hierarchy, because when you do GameObject.find, it searches it by name, so if it's not exactly the same, and as you can see there, I did actually call it the destruction tile map. So always handy just to make sure that if you're going to be grabbing anything like that, to make sure that names are exactly the same. So let's go ahead and open this up. So now we've ensured that we actually have the tile map. We then want to actually, it looks like I have missed out on one more variable, and that is we're going to make a private list of vector3 ints. And whenever you're using tile maps, they will be using vector3 rather than vector2. It's a bit annoying. I don't really understand why, because they are in themselves only really a 2D thing. But yeah, just keep that in mind. Although the X, Y, and Z are exactly the same. So we're just going to be making a list, and we're going to name that tiles to break. And there we go. So we're going to add all of our tiles there, and we'll use them later. So actually, let's get started on that now. So tiles to break equals, and we're going to use a custom function for this. So let's call that get affected tiles. Just there. And once you get to the end of this line, if you do Alt Enter, it will come up saying generate method. If you press enter again, it will just create it down here for us. But before we get to that one, let's just add in our other functions that we're going to need, which is a private vector2, and this will be get direction from impact position. So once we have our impact position, we want to be able to figure out which direction to actually break the walls. Because if you, let's say you want to use this for a ceiling or the floor or left or right side wall, we want to be able to make this, and then it can decide based on its environment on which direction to actually take, because we don't want to have to code it individually every time. Okay, and let's turn that into an actual function. So just do return, let's just borrow that. So we've got our two functions just there, and I believe, no, we just need one more, which will be our private vector3 int adjust start position, which, as I said earlier on, is just because when you have a decimal spot in your position, that's not the location of the tile map, so we need to be able to filter that through, basically. Okay, and then the last and final that we are going to need is just a fixed update. Now, the reason I'm using a fixed update here, although you can use a normal update, is because we're going to be spawning game objects and making adjustments to them. And because of the way that the fixed update works, I mean, I think it's around every 50 frames or something like that. It doesn't run necessarily every frame. So because of that, this is going to be helping with performance a lot, because of what we're going to be putting in here. It's going to be a lot of computing power. I say a lot, it's not like massively a lot, but anything to get some performance is always better. So now we've got our fixed update, we've got 3 functions, and we've got our start finished. Let's go ahead and get the direction from our impact position. Or actually, let's move this one above, because we'll be going down like this. Or not down like this, but they'll be going in this order. Or, sorry, yep, I'm actually wrong again, because they'll be going in this order. Just to keep it nice and clean and easy to read. So let's go ahead and do the get affected tiles. Now this one's going to be a bit of a lengthy function, so just bear with me a second. Right, so let's get rid of that. So first of all, we are going to want to get some variables in here. So the variables that we're going to be using are vector2 impact position. So that'll be the position that we actually are hitting the wall from. We'll have another one, a vector2 int, which will be the impact radius. So how far the walls will actually break from the impact position. And then we'll be using a vector2 for the direction. So from here, if the impact radius equals vector2, no, we can't use 0 on that, so we'll just have to make a new one, just like so. So we're just saying if the impact radius has not been set, it will equal 0, 0. So we're going to set that here by default minimum. And of course this can be your choosing. The impact radius equals our default radius, which we have just up here. And we will be able to add in the inspector. So if you did want to, then you could pass through a custom radius, which will be different to your defaults. Let's say, I don't know, you've got a hammer that can do a 5x6 versus a pickaxe that can do a 1x1. I don't know, something like that. So from there, we are then going to want to create a new list. So let's go ahead and make a list, and this is going to be of vector3 int of all tiles. So this will be all the affected tiles, and we'll just make a new list there, or an empty list even. And then because of the nature of how we're going to be deciding our direction, once we know which is our forward, so basically which direction we're going in, we are then also going to have to spread out either side from that, as well as continuing in that direction. So we need to be able to find what is our right and left in that direction. So to do so, we can quite easily just add one line here. So we can create a vector3, which will be our right direction. And then for our left, we'll just make this a negative number, or a negative value, equals quaternion dot Euler. And now this is going to be our angle, so we're just going to add a minus 90f times direction. So what this does is it takes our direction, our direction, it then turns it on 90 degrees on the z-axis, and then that is our right direction. Now, I know this is minus, but if this was plus, I don't understand why, but it just goes the other way. So just have faith there. Right, so now we've got a list for all of our tiles to go into. We've got our forward direction, and our right direction. Now we actually need to start getting the tiles, but to do so, we need to get our starting point. So let's add that in now, and then we can continue with the rest. So for the actual start point, because all tiles are integer values, or not integer values, but integer spaces, we're going to make a vector3 int, and I'm just going to call this the start position equals adjust start position. And in there, we are also going to be adding our impact position, our right direction, and the forward direction. And let's go ahead and add that in just here. So that is going to be a vector2 on the impact, vector3 for our right direction, and for our forward direction, again, that will be a vector3, I believe. No, sorry, that is a vector2, so it's just up here. And there we are. So now that we've gotten to this position to this point where we're going to need our start position to be able to continue any further, let's go ahead and get started on this custom function just here. So to get our starting position, first of all, we need to figure out where our impact point is. Then we need to figure out where the next tile is. So to do so, we're going to just quickly make a vector3 int to output. Because it says vector3 int here, it means that this custom function is going to output that information. Otherwise, it would just be a void. So we're going to have our position equal just a new vector 3 int, because we haven't got any information for it yet. And then we are going to go and do if direction equal dot x equals 0. In a moment, I'm going to be setting it up, or we're going to be setting it up so then the direction is 0 to 1, or minus to 1, to be able to show us the actual direction. So if we're going right, then the x is going to change and the y is going to be 0. If we're going up or down, then the y will change and the x will be 0. So I'm just using that here in an if statement, just to be able to differentiate between the axes. Axis, axi. So then we're going to do the same thing again, but with the y-axis instead. Okay, so let's just add a little offset in here, just to make sure that this is all going to work. So that would be an int offset, and if direction dot y is more than 0, so we're going to the right, the offset equals 1. Now, because of the way that the tile maps are set up in the grid space, we're actually going to make the next offset equal -2 for going left. Now, it would make sense to make it a -1, although I've found that it just does not work like that at all. I'm not entirely sure what it is, but I think it's just because of the spacing between the Unity units. But so yeah, so let's go ahead and just copy that down below as well, because it's going to be exactly the same. And then underneath that, we're going to go position equals new vector 3 int, and we're going to do impact position dot x plus the right direction, because this will be going up and down. We'll be making that change on the x axis, because we know that by choosing or deciding our axis up here. And then we're going to want to get our y axis, so that'll be the impact position dot y plus offset. Nope, not that. And then we're just going to leave the z axis as 0. And of course, it's come up with red squiggly lines, which nobody likes, so let's go ahead and convert these into ints. So just put those into the brackets there. So in case you're not sure on what I've just changed there, I've just added the int inside the brackets and then put these inside their own brackets next to it. And there we are. So now what we can do is just basically copy that again below. So we're going to do position equals new vector 3 in, but then this time is going to be the other way around. So it's going to be impact position dot x plus the offset, and then if I can spell, the impact position dot y plus the right direction, and again with 0 on the z axis. So let's go ahead and just put some nice brackets around this to make sure that Unity is going to be happy, and of course make sure that you also have your dot y on the end there as well. And then we just want to output this. Let's just return position. And there we are. So now we have our start position selected based off our impact position. And now we are going to get the direction from the impact position, because as you can see there, we do actually need our direction. And we are going to need to be inputting that right at the top just here. So let's go ahead and clear this quickly. So to start, we're going to want our vector 2, which will be what we're outputting as the direction, and we're just going to make that a vector 2 0. We then need to be able to get our actual position, based off of our standard offset. So this is going to be the conversion between where you impact and the tile map, the grid location. So like I was saying previously, instead of inside the square, it will be in, I believe, the top left or the bottom left corner. So that again is going to be a vector3 int. We'll just name that position equals new vector3 int. And again, just like up here, we're going to add in our offsets. So just here, let's make that an int. We'll also make more brackets. We'll do impact. Of course, we haven't actually added this in, so let's just go ahead and add that here. So that's just going to be a vector2 impact position. Okay, stop recommending me the wrong things. Dot x plus offset dot x, which we will be setting in the hierarchy using the variable that we've created just up here. And again for the y-axis, is impact position dot y plus offset dot y. And our z-axis will just be 0 again. So now we've got our offset position, we need to figure out what direction we're actually going in. And to do that, we're going to be basing that off of where the closest tile is, which is why we need our offsets. So let's go ahead and do that. It's just going to be a couple of if statements. So we're going to go if, and we're going to use a tile map for this as well. So we're going to get our destructible tile map dot get tile, and we're going to check for at our position. So we're going to check if there's a tile in this position that we've just set. Position plus a new offset. So we're going to go new vector3 int, and so this is going to be a check for up, down, left and right. So in order to do that, we can quite simply do 1. So we can do a 1 on the x-axis, and that will go to our right. That will move 1 space over. And our direction, let's make sure enough are in there. Direction.x equals 1. And let's just add a little comment. Right. And if we don't have something on the right, we're going to go else if, and basically just copy this again. And once you have that line, you can just copy it another 2 times. Nice and easy, nice and simple. So we're going to go right, left, up and down. So we're going to check in each direction to see where the impact is actually going to be taking effect. So let's just fix these up, so then we make sure that they're actually working. So I'm going to leave left and down for the moment. Let's just sort out up. So up is still going to be 1, but we're going to be changing it from the x to the y. Now, just like up here where we've done the -2 instead of -1, we're going to be doing that again here. So I'm going to place in -2 on the left axis, and then a -2 again on the down axis. However, our directions can just go to -1, because this will be used as a deciding variable rather than a factual variable. So we aren't actually moving 2 spaces over in when we're going to be selecting our tiles. We're just going to be moving 1 at a time. So this is okay. And then we just want to return that information. So return direction. So now that we have our deciding direction, let's go ahead back up to the top and just fill in this custom function calling. So the original position is going to be our transform.position, because we're going to be spawning the game object that runs this script into the world. And then we're going to use our default radius, but of course you can change this if you'd like. And then we're going to be adding in our new custom function, so we can just go ahead and copy this just here into the top, and the impact position is just going to be transform.position. Nice and simple. So let's head back down to our get affected tiles and continue getting our tiles. Okay, so now that we've got our start position based off our direction, we can go ahead and do if destructible tile map dot get tile start position. So what we're going to do here is we're just going to make sure that our start position is actually on a tile, because if it's not on a tile, we don't want to do anything else. Basically, that's just a false calling, or it may not even be anywhere near a tile map. So we don't want this code to run if it's not actually going to do anything. So we're just going to turn that into an if statement, and then we'll pack everything into here. So to get started, we're going to need another list. So we're going to do list vector3 int, and we're going to call that start tiles, and just turn that into a new list just there. And then from here, again, we're going to need to decide how we handle this based on the direction that we're looking, or not the direction that we're looking, but the direction that we want the damage to occur. So similarly to what we've done just here in the adjust start position, I'm going to use these if statements again to make sure what axis we're actually on, because of course we can't be on two axes or axi at the same time, because that would be diagonally, and although it's possible to code that, it would be a lot more difficult than just be going in a straight line. So maybe I'll revisit that again in the future, or extend this tutorial. Yeah, if it's something that you're interested, definitely feel free to let me know. Right, so now that we've got our two if statements just there to make sure where we're going, let's go ahead and add some comments. So this one is up and down. This one would be right and... Actually, no, I like to start with left, so left and right. And let's add a couple more comments into this as well, just and then if you do come back and you're not sure what you're looking at. So, up here, if no radius is applied, use default. And then we are going to go right here, get starting position. I feel like, let's add this in. So get starting position, offset from impact position. There we are. And then just in here, just above these two if statements, get affected tiles from start position. So in our first if statement, we're gonna be running through the tile positions based on the range or radius of the destruction. So in here, we're gonna go ahead and make a for statement. And if you just type in for and press tab twice, it will fill in the rest for you. But we're not actually going to be using 0. We're going to be using minus impact radius dot x, because we are going to be going left in the direction that it's facing. That we're going to be going basically from the center, left and right at the same time. So we'll be doing that from minus until the impact radius dot x. Yes. And yes, that is a vector2 int, so we can just leave that as it is. So from there, we're going to be going in two directions, so we can do that quite easily with a vector3 int pos1, and we'll do that from the start position, and then add on a new vector3 int, which will be the I. Let's change this to y, because this is actually going up and down, as we've stated here. However, I've just realised this is actually wrong. So let's change that to x, because so the initial starting point or the starting points are going to be on the x-axis going left to right, but the actual damage is going to be going up. So that's what we're going to be doing here, just getting the starting positions. So we'll add in our x, and then we'll go 0, 0. And we'll just add another comment in here. Fan out from center start position. And then from here, we just want to make sure that there's actually a tile there. So we're going to go ahead and do if the map dot get tile pos1. So this in itself is a bool statement. So just running this line of code will give us back a true if there is a tile, or a false if there isn't, just like we've used up here. But we're also going to want to make sure that our start tiles doesn't actually, we haven't already tried to use it or add it to our list. So let's go ahead and do and with an exclamation mark for a false start tiles dot contains pos1. And then if it doesn't contain this position, we'll add it. So we just do start tiles dot add position 1. Now we're just going to go ahead and copy this just underneath, and instead of plussing, we're going to minus, because we're just going to go in the opposite direction. Of course, we can't have two variables named the same thing, so I'm just going to change this to pos2. And there we are. So that is getting our starting points from the up and down. And then from there, we're going to want to get our depth. So we're going to do for each, because we already have our row of starting points. Now we want to go deep, like up. I'm not sure how to, the best way to explain that. So let's go ahead and just do a for each statement. And we're just going to call this a point. We're going to leave it as a var. And we're going to be doing this from the items in our start tiles. So for starters, we actually want to add these, the starting tiles to our tiles. So I'm just going to do all tiles dot add point. And then again, just like we've done up here with a for statement, I'm going to use that again just in the y-axis. So we go for, I'll change this to y, except we can leave that as 0 and do impact radius dot y, just because we're not starting from the middle, we're starting from the very end. And then again, vector3 int pos, we'll just call this pos because there's only one, equals point plus new vector3 int y. No, not y. 0, y, 0, because we'll be going on the y-axis. And then we can just end that line and go if the map dot get tile pos is true and all tiles, our list that we've created just up here, does not contain the position, we'll add it in. Now you may be wondering, but this is only going to go in one direction. So let's go ahead and just add in a multiplier. So we're just going to have a normal int that we can times it by. So let's just add that in here. Multiplier. Why can't I spell? I am spelling correctly. There we go. Multiplier equals, not equals. We're just going to leave that as that is, and then we're going to have an if statement that says if the direction dot y is more than 0, so we're going up, then the multiplier equals 1, else the multiplier equals -1. And then we can just times our y by that to change direction. So if y equals 6, you times that by 1, we're going up, that's just 6, but you times it by -1, it's -6, and then it starts going down. And I believe that is all we need for that side. So let's go ahead and do our left and right, which is pretty much the same, it's just making sure that the directions are correct. So we are going to need, again, another for statement, which will be our x-axis. Well, no, in this case, it's going to be our y-axis. Again, we're going to go minus the impact radius of x, with our length being the impact radius x again, to get from as far left and as far right from the middle. And then we're going to go vector 3. So in fact, we can actually just copy these and then make some adjustments. So our x is going to be in the center, or our y even, so it'll be 0, y 0. And then again, just down here, 0, y 0. And the rest of that is exactly the same. Let's grab our multiplier again. To change the direction dot y to direction dot x, because we'll be going left and right. And then underneath that again, we want our for each statement, so we can just go ahead and copy all of that, plop it down underneath, make it look nice and tidy, and then just adjust our values. So it says y here, so let's just change that to x. And they didn't all change, so let's just go through. Make sure we don't change the impact radius, because that's going to remain exactly the same. However, we can move our y times multiplier and put that as x times the multiplier, because we'll be going along the x-axis, and then make the y value 0. And there we are. So now we have got the affected tiles. So we've actually got the tiles that we're going to be using, or destroying, I guess. And then at the end of this if statement, or the custom functions, let's just follow the lines. We're going to go ahead and return all tiles. So what this is going to do is basically it's going to start with 1 point, and depending on the direction that the impact is going, it's going to get a plane and then add the depth, and it's going to pick up all the tiles within that range. So now we can go ahead and get to our update function, which is going to be a lot shorter but still contain some quite heavy code. So because this is going to be running almost constantly to make sure that we don't miss any tiles, we're going to go ahead and do if tiles to break dot count is more than 0, because we're setting our tiles to break just up here using the get affected tiles. And then we're going to be doing our magic in here, but otherwise we're going to do else destroy this dot game object, because if there's no more tiles to break, we want to go ahead and destroy this object, and then it's not in the world and sucking on our performance basically. Okay, and so like I said earlier, I'm going to include a timer in this. You don't have to use it. You can just set these to 0 or not implement it at all. But just in case you do, I'm just going to add it in here. So we're going to go if update timer is less than max time, update timer plus plus, and then else, and this is where we'll do our function, but we'll also want to reset the timer, so update timer equals 0. And let's go ahead and do our function above this. So we're going to need 2 more lists, and let's actually just add in some more comments. So this will be converting tiles in list. So what we're going to go ahead and do is we're going to basically get the tiles that are in the position, we're going to get rid of them, and we're going to spawn a game object in instead. Because you can't interact with a tile, but you can interact with a game object. So to do this, we're going to need a list again. And we're just going to make a vector3 int. And we're going to call this one tiles to remove from list, so that because we're going to be using a for each statement in just a second, if you try and remove something from a list while you're doing a for each statement, because it's cycling through the list rather than using numbers like in a for statement, it will punch out an error and say, wait, hold on, this isn't the same list, what's going on? So instead we're going to add it to a separate list, and then we can handle that later. And then we're going to need one more list, which will be our destruction, not source handler, it should be visual handler. What did we call that? Yep, that is spelled correctly. Not sure why that's not coming up. Destruction visual handler. We'll just call that converted tiles equals new list construction handler. Just like so. Now let's just double check on why that isn't doing anything. I'm just gonna go ahead and open this up just to make sure. Maybe and that'll be why, because I can't spell destruction. There we go. I knew the R was missing, I just didn't know where. And there we go. So now you should be seeing this just here, or hopefully you can actually spell. So now that we've got our lists, we actually need to go through the tiles and figure out whether we need to remove them or whether to convert them. So I'm going to do a for each statement here. So we're going to go for each, and I'm going to leave it as var. We're going to change that to tile, and the collection is tiles to break. So first of all, we want to get the position, which will be vector3 int, and we'll just do position. We'll just name that position equals tile, because the actual list is the vector3 int, so we can just pull that information straight away. But because it is a vector3 and we want to make sure, we're just going to change the position.z to equal the same z as our timeout, which is just done like so. So tilemap.transform.position.z. Now the reason I'm adding this in here is because sometimes I find that changing the Z of the tile map might be a great way to change how it's visualized in the game. However, it may not be the case on your game, so you can take this out if you like, or you can set the Z, but I just thought I'd add this line in so you know where to do it. So of course you can change that if you would like to. And then after we've done that, we want to go ahead and make sure that the tiles are still there. just in case for some reason they might not be. You might be able to edit them in your game, but let's just make sure that they are actually still there. And I'm going to add in our position like so and make an if statement. We're then also going to want to make another if statement. So if the tile is there, we want to make sure that it's not on our tiles to remove list. So let's go ahead and do the same thing, but we're going to add an exclamation mark to say if it's not on our list, continue. So we're going to do tiles to remove from list dot contains position, just like so. And in case the tile isn't available, we're going to add it to the tiles to remove list. So just here we do else tiles to remove from list dot add position. So back over here, we're going to now turn the tile into a game object. So let's go ahead and create a new game object that we can reference. So I'm just going to call this new tile equals, and we're going to instantiate, because we're going to be creating it in the actual game world, tile splitter prefab at our set position of the tile, and we want to keep the same rotation, so we'll do quaternion dot identity. We then want to get the visual handler from that, so let's go ahead and do so. We're just going to make another variable, destructible or destruction visual handler. I'll just name that handler equals new tile dot get component destruction visual handler. We're going to leave that there for the moment, and we'll come back to that because we're going to need to work on that script, and at the moment it's just your standard basic script. So we're just going to add in converted tiles dot add. So we're going to add the handler to our new list that we've made just up here, and then we want to remove it from the list and our tile map. So we'll do the map dot set tile at this position, and we're going to set that to null, and then we're going to do tiles to remove from list dot add position, just like so. So now that we've got that there, we need a way for this list to actually like work and be useful. So just underneath, we'll just add a for each tile in tiles to remove, and then we're just going to go ahead and remove them from here. So tiles to break dot remove tile, and then under this, just in case for whatever reason that doesn't work, oh no, that should work, sorry, I'm getting confused. After this, we want to clear our tiles to remove from list. Reason being is because we can't remove them in our for each statement, and to be honest, we can just clear them all like so. But we don't want to do that to our tiles to break in case there's more that we haven't actually done here, which is why we've got it under an if statement like so, because if there is still more, then it will continue and loop. So before we go any further, let's actually head back into Unity and let's get some prefabs made, so then we can actually get these scripts attached. And of course you always open. Right, so we have our impact point, just like so, that we're going to be wanting to add our script to. So let's just do that here. So we've got our script, and let's just add in some details. So the timer, again, if you want to add the timer, you can do. I'll show you what it does in a moment. But otherwise you can just leave that as 0 or not even include it. It's completely up to you. So the offset, we're actually going to keep as 0 for the moment. But again, if for whatever reason you need it, this is where you'll do it. So let's say it's coming up with this point as your start position, but you actually need it to be here, then you would add your X to be 1, and again the same in the Y axis as well. Now our default radius is just going to be 3 by 3. The destructible tile map, we can drag this in, but in the code it'll also grab that if it's not been allocated. And then our tile splitter prefab, which we're going to be making now. So head into your hierarchy, and of course always remember that's not a very good sentence there, but always remember to save your project. So right click in the hierarchy, new game object, empty, and we're just going to call this tile splitter object. No, let's call this tile splitter temp, because this isn't going to be staying in the world for very long. It's just going to be splitting a tile into multiple sprites. So let's go ahead and see what we need on here, which is the visual handler. So just go ahead and drag that over, and I can see that our positions are all a bit funky at the moment, so let's just make sure that these have all been reset to 0, 0 and aren't all over the place. Let's just zoom out so we get a better view in there as well. So let's go ahead and open a destruction visual handler. Now the reason why we are creating a game object for this and not doing it in the other inside this script is because this script is making all of the tiles. So we need those tiles to be in the right positions with the right sprites, and unfortunately we're just not able to do that with one single script. We can, but for the efficiency of the workflow, it's better to spread it out. So let's get some variables in. Public. So we're going to want a sprite for the tile sprite, and these public variables are going to be the information that gets carried over. So we're going to want the tile sprite. We're then also going to want the force direction. So if you want them to be thrown around, then the direction that they're going to be thrown in. So force direction, or sorry, force position actually, that's my bad. However, we will still be working on that in a moment. We also want the force speed, so we can use that as a float, which will be the force speed. And now this one we will be setting to the prefab rather than inputting. So let's just actually add that as a comment. Set on creation, input in adjusted in inspector. However, I'm going to leave this public in this. The way that I'm setting it up, I'm not changing that force speed by code. Although if you did want to, then you can leave it as public, or you can change it to private if you'd like. Okay, and then we're just going to need our references. So let's go ahead, and I'm going to make these serialized fields because they are going to be private, but we want to be able to access them in the inspector. So that's going to be a game object of the prefab. So this is going to be the actual individual tile, not tiles, the broken tiles, sorry, the actual prefab for the broken tiles. We're gonna make that in a second. So we're gonna go ahead, serialized field again, private game object, and we're gonna make a parent prefab just to help clean up our hierarchy. And then another serialized field, and this will be a list of sprites that we'll use. Can you not? Nope, that's why, because I'm in the wrong place for that. Sprite masks. Now the reason why we're going to be using masks is because this is going to be the easiest way to break apart a single tile into converting a tile to a sprite, and then trying to break a sprite apart almost isn't possible with basic coding language. It like to be able to do it properly, you would have to kind of code your own rendering process. However, this is a cheaty way around it, I guess, which doesn't bring on a lot of load in the performance, but it's a much easier workaround. So now that we've got our variables in, we are, and sorry, one more variable. So I'm going to add in private int apply force timer, and force time equals 10. Now this one I don't recommend removing, just because it allows the game or the application or the processing to actually catch up with what's going on, because you don't want everything happening at the same time. If you have everything happening at the same time, then it's just like going up to somebody and throwing everything at them at the same time. They're going to be overloaded. And it's the same thing with computers. So you have to keep that in mind when you're coding these things. So we're going to use a timer just to kind of add a little bit of a delay, but it won't be noticeable once it actually happens. So now that we have actually got all of our variables in, we're just going to make a simple start function and add in another function below, which is going to be public void, and actually no, this one can be private void break sprite to masks. And we're just going to go ahead, turn that into a full. We're going to add that into the start. So you could make this public and access it from another script, for example, when we're spawning it. But I prefer to have it here on start, just because then you know it's going to happen from the moment it enters into the game space, and you don't have to wait for the delay from another script. So now that's in, let's go ahead and get this function going. It's not an overly complicated function, but it is probably one of the most important. So to get started, we need a list of game objects, which is going to be our new objects that we'll be spawning in, and this will be the broken pieces. We will also want to create our parent object. It's going to be game object parent equals instantiate. We're going to use the parent prefab, and we're going to spawn that exactly where we are in the game world, with our rotation keeping the same. And then underneath that, we are going to create a for statement. Actually, let's just hide that gap there. So we go for I equals 0, and then I is less than sprite masks dot count. Now, the reason why we're using this will make a little bit more sense in just a moment after this script is done. But essentially, what we're doing is so the reason why we have a list is because we're going to be adding multiple masks to apply to the multiple sprites that are going to be added in. And because we're going to be adding that into a single list, this will tell us how many times we need to break that sprite down. Or not break it, but create a new version of a sprite. So after you've done that, we're going to want to go ahead and create a new game object for each one, which I'm just going to call new GO for new game object equals instantiate, and this will be the normal prefab. And then we're going to go ahead and get our transform.position But we also want to offset this, because when you go into tile maps, they don't actually equal a full number. Although they have a 1 space gap, if you see over here, it's got the tile anchor, that's 0.5. So if I change this back to 0, you'll see that the tile map is actually moving around. So let's go ahead and add that in there. So plus new vector 3 for the offset, which will be 0.5f, 0.5f, and 0. And then we want to keep the same rotation. So quaternion dot identity. And then let's just go and add that to our list. So there we go. Look, it's already recommending it for me. New objects dot add new geo. Now I'm just going to leave this line here because we are going to be adding an extra function in just a moment, but that will require another script. So let's just continue. And then all that we need to do once we add them in is just apply some force, which will be if apply force timer is less than force time, apply force timer plus plus, else and then so the time is going to go up and up and up until it reaches its maximum, and then after that's done, using our else, because it will be higher, we will just add a for each function, and that's going to cycle through the rigid bodies in our new objects. Now these are game objects, but let's just call them rigid bodies so we know what's going on here. So before we actually apply the force, we need to get the direction. So let's go ahead and do vector 3 force direction equals transform dot position minus, and we're going to have to turn this into a vector 3 because it's imported as a vector 2 force position. Now, if you didn't want it to do this and you all wanted them to go in the same direction, then you can just use force position. But for a better visual, it's better to have it come from the actual impact point. But again, it depends on what sort of project you're working on. And then under this, we're going to have rb dot get component rigid body. Make sure it's the 2D, and then dot velocity equals force direction times force speed. And then underneath this, because everything's all been done and we no longer need this game object, we're just going to go ahead and destroy it. So destroy game object. Now just here we are going to be using a static script, which isn't going to be in the game world or attached to a game object, but it is going to be accessible to us. So we're just going to need it to run a little algorithm for us, or not really an algorithm, but more of the chores that we don't want to put them on the game object. So let's go ahead and open up our sprite updater. Get rid of all of that. We'll remove our mono behavior, and between public and class, let's just add static. This allows us to access it without it being attached to a game object. And underneath, we're also going to want to add another class. So I'm going to do public static class, and I'm going to call this the collider. Actually, no, let's call this update collider to sprite. There we are. So what we're going to do here in the update sprite well no, the sprite updater is, once we've spawned in the new game object, we want this to take over and manually update everything on that game object to exactly what it should be. To have it interact with the world, we're going to have a collider attached to it. Now, if you change the sprite while you're playing the game, basically, there's a lot of things that can go wrong with the collider because it doesn't automatically update itself. So what we're going to be doing in the update collider to sprite is doing it manually. And we're actually going to force it to do it to make sure that it's exactly what it should be. So let's go ahead, and in the sprite updater, we're going to add a custom function, and that's going to be public static void update sprite object. And what this is going to do is it's going to go through all the sprites, or all the new sprites that we've spawned as game objects, as the broken parts of the original tile. We're going to need a few things up here actually, so let's go ahead and add them in. So we're going to need the parent object, we're going to need the list of new game objects, we are also going to need a list of the sprites that we'll be updating or adding, the original sprite of the tile, so then we can make sure that it actually doesn't change what it looks like, and then the physics material, which is going to be physics material 2D, and we will just name that physics material. Now you don't have to have the physics material, but if you want to change the friction or the bounciness of it, this is where we're going to do it. Okay, and now that we've got that function, we're going to go ahead and make a for statement. So for int equals 0, I is less than new game object dot count. You could also use the sprites dot count, but essentially in our visual handler we're using the sprite masks, or the number of sprite masks, to create the game objects. So we shouldn't really need to, but essentially there should be an exact same amount of objects comparatively to the amount of sprites. If there isn't, unfortunately I'm not sure what would go on your end, but it might be worth just having a look back in the tutorial on why that may be happening. But using these for statements, they should only do what's necessary. So now that we've got our for statement, we're going to go ahead and update our new game object. So let's go new game object, and we're going to do brackets, the squared ones with an I in the middle, because then that will get the number that it is inside the list, because they'll all be added in a sequential order, and then you can just use the I to pick out which one without it being random. So let's do new game object dot get component rigid body 2D dot shed material equals physics material. Again, if you don't want to add this in, get rid of that line. If you do want to add that in, great, leave it there. And then after that, again, we're just going to do new game object dot get component sprite renderer sprite equals sprite. And again, this is the reason why we are using these lists, is because now I'm able to access the same sprite which is numerically corresponding with this game object. Okay, and then we want to add a polygon collider. Dot get component polygon collider. Oh no, sorry, not get component, add component, because we're going to be adding it to the game object. We are going to be setting it up as a template, but the polygon collider, just as a test, I prefer to add it in, just because we're not going to want the collision to be happening straight away. So when we add it in here, we can actually decide when it's going to happen. I know you can enable or disable, but just not having it on there beforehand is kind of a better way to do it, because we don't need it yet anyway. And it's only one line of code. So after that, we're just going to add our physics material to our polygon collider as well. So new game object I dot get component. Get component polygon collider shared material equals physics material. Now just here I'm going to leave it blank because we are going to be using a custom function from our update collider to sprite just under here after we've already added it in. But just a couple of lines underneath that, let's continue, because there are a few other things that we can do now, which will just be, again, we're just going to update this game object with everything that it needs. So dot get component, dot transform, dot get child, and we'll just do 0 because it'll only have one child. Dot get component sprite renderer dot sprite. So just here, what we're coding now is essentially we're going to have a main sprite that is visible, a sprite that handles collision, and a sprite that masks the visible layer. And the mask itself is going to be what makes it look and act like a broken piece. However, the full sprite is actually going to be used. So let's just add that here. We'll be using the tile sprite that we pulled from earlier. Okay, so this is our visible sprite that we've just added, and then we're going to add our mask. So new game object I dot transform dot get child again 0 because it will only have one child, although 1 equals 0 in code. Get component, and then we're going to get a different component, which is the sprite mask. I'm going to go ahead and get the sprite from that and set it to the sprite from our sprite mask list. And then we're just going to set the parent of the new game object. So new game object I dot transform dot parent equals parent dot transform. And then one thing that I just like to do, just to make a visual representation of it breaking, is a new game object I dot transform, and we're just going to make it shrink just slightly. Just then it actually looks like it's breaking rather than coming apart, or it's like been hit or impacted. And we're just going to do times equals 0.95f. But of course you can change this if you want to change the scale, or you can leave it out completely if you want to leave it as it is. Okay, so that's it for the update sprite object. We just need to go into the update collider to sprite and update the collider to the sprite. So we're going to add a couple of custom functions in here. So we're going to do public static void try update shape to attached sprite, and we are going to need the polygon collider that we are going to be updating, so let's just add that in there. And then underneath we're just going to do private static void update shape to sprite, and we are going to just be adding that into our custom function just here. So although we can call this directly, we're just using this as a stepping stone in case you want to add anything else in there. If you didn't, then you can just call this function directly and make it public. Or in fact, let's actually do that now. Yeah, let's get rid of that one. And let's just use the one function and we'll make that public. So in here we're going to need a couple bits of information. We're going to need the polygon collider. And actually, yeah, we can just use the collider. And then underneath, we're going to get the sprite. So we'll just do sprite equals collider dot get component sprite renderer dot sprite. So we've just set it there, so there's no need to input it. And then underneath there, we are going to make an if statement. So if collider does not equal null and the sprite does not equal null, because again, it's always worthwhile making sure that things are actually there. Like if we have a collider but it doesn't have a sprite, then there's no point in running this code and it's not going to work. But if we have a sprite and not a collider, for whatever reason, it's still not going to work. So after that, we're just going to get our path count. So collider dot path count equals the same as the sprite. So sprite dot get physics shape count. And then we want to make a list that we're going to add our path into. So we're going to do a vector2 path equals new list. And essentially, so the sprite dot shape count is going to be the points at which it kind of like goes around the shape, and then the path is actually going to be the path. Yeah, so this is the number of points, and then this is actually going to be where those points are relative to the shape and the object. And then after that, all we need to do is just a for statement. So we're going to do for I equals 0, I is less than the collider path count, and we're going to do path dot clear. We're going to get the physics shape, so sprite dot get physics shape. You're going to add I path, and then we're going to set the path to the collider. So we're going to do collider dot set path I path dot to array. So essentially here what we're doing is we're just clearing all the defaults from the collider and the sprite, and then we're just saying to the collider, right, this is the new sprite, this is the sprite that you have to listen to, and this is the information you got to listen and process. And then the collider is actually going to make sure that the collision box is exactly how it's supposed to be, because a polygon collision or collider wraps around the image that's being displayed. And of course, if we're changing them and adding masks, then that image gets changed a couple of times, which is why we're going to do this to make sure that it's exactly the right collide or collision that we actually want. So now that's done, we can go ahead and add that in up here. So we're going to do update collider to sprite dot update shape to sprite, and then we're going to go ahead and add our collider, which will be the new game object I dot get component, and that'll be our polygon collider that we've just added just above. So we're going to add it, we're going to set the physics material, and then we're going to update the actual collision box. I know I've got these red squiggly lines, but that's just Visual Studio being a bit of an at the moment. Okay, so that's all done with that script. Let's head over back into the visual handler, so then we can continue, or not continue, but we can just add this in here. And so it's just a single line we're going to add in, which is sprite sprite updater dot update sprite object, and then we're just going to pass in our information. So what's happening here is we're making all the new game objects individually, and then we're going to update them all after they've been created, rather than updating them one at a time as they're being created, just to share the workflow out a little bit, so it's not all happening in one section or one instance, although it will be happening on the same frame. So in here we're just going to pass through our parent, the new object list, the sprite mask list, the original tile sprite, and our physics material. And just like so, we have our source handler done and ready to be used. We have our visual handler, and we have our sprite updater. And again, this doesn't need to be added to a game object, as it will run straight from the files. So there's just two more that we need to do, but I think we can get some more prefab set up first. So you may have noticed that when you go back into Unity, it'll give you an error of the physics material. We just need to make a new variable at the top. I just forgot to add that in, so let's just go and do that now. Public physics material 2D physics material, and that will go ahead and fix the errors. Okay, so if we go back onto our tile splitter temp, you'll see just over here we've got all of our information that needs to be added. So let's go ahead and make the remainder of our prefabs. We'll finish off these two scripts, and then we will get this up and running, so then you can actually see it working. So let's go ahead and make a prefabs folder. I'm going to go right click, create folder, and just name that prefabs. We can also just make another folder, name that scripts, and drop in our scripts. Now, annoyingly, it will mean that if you go back to Visual Studio, or whichever IDE you're using, you will have to close them down and just open them up again, but it's no biggie. Let's just go ahead and do that like so. So in our prefabs folder, we're going to drag in the impact point, the tile map, or the tile splitter temp, and you don't have to, it's completely optional, but if you want to package it up to be reusable, then you can drag in your destructible tile map. Now all we need is just two more objects, so let's go ahead and create empty. One is going to be the destruction parent. So this is what all the sprites are actually going to be parented to, and then we just want another one for the sprites themselves. So I'm just going to call this broken sprite, and drag those in as well. So for the destruction parent, let's just go ahead and add a new component, which is the destroy on empty. And let's open that up, get rid of all of that, and we can leave the mono behavior. And all we need in here is just a simple update function, which just says if transform.childCount is less than or equal to 0, destroy object. This just means that if we don't have any objects underneath of us after they despawn, destroy yourself before you wreck yourself. And that is the parent done. So let's go ahead and just make sure that saves to the prefab. So you can go over, click on overwrites and apply all, or you could right click and I think it comes up in this menu as well. So then if we move to our broken sprite, we're going to need a couple of things on here. So we're going to need our rigid body, so then it can interact with the world, and we'll set that up in just a second. We're going to want a sprite renderer, to display the sprite, and then we want our fade out handler. Oh, I'm not making a new script, just like so. And let's go ahead, save that to the prefab. And if we head back to our main assets folder, let's also create a physics material. So if you right click, create, and you have the 3D physics material here. Make sure you don't use this one. If you go to 2D, there is actually a 2D version just there. So I'm just going to name this broken sprites, just so then I know what it's for. And we're going to go ahead and set that to 0.5 and 0.1, just so then they do have a bit of friction and a tiny bit of bounciness. Obviously it's going to be a wall, so you don't really want it to bounce around or move around a lot, but you also don't want it to hit the floor and just stop. So that is that done. Let's go back onto the broken sprite and drag that into our rigid body. We're going to leave that as dynamic. We're going to change our mass to 10. We're going to keep discrete collision detection, start awake. We're going to change interpolate to interpolate. And we're going to leave the constraints alone, just so then it can move and rotate. Go ahead and apply all again. And that's our rigid body set up. As for the sprite renderer, there's absolutely nothing that we need to do. The next part of this would be the fade out handler. So if you want to go ahead and open that up, we'll get rid of the starting code and let's add in our variables. So we want to be able to edit this from the inspector, so then we can adjust our prefab. So let's go ahead and give it some variables. We're going to make them serialized, private, float. So the first one is going to be the fade speed. If the fragmented piece of the sprite gets too far from the camera, there's just no point in rendering it or keeping it, because it's going to fade out before you even get there. So we might as well just destroy it and give up some performance for the rest of the game. So I'm just going to call that destroy distance. So one more, we just call that private in force fade timer. So we're gonna have a couple of conditions that start the fade, but we want to make sure that the fade is always going to happen, and that's what that is going to be for. We're just going to make a couple more, which are just going to be private and we won't need to access, and that's going to be the rigid body 2D, and we'll just name that RB. We're going to make a pool, not public, private, a pool. God, I can't speak or type at the moment. We're going to name that start fade. You could make this public if you like, but for my project I don't need it to be, so I'm just going to keep it like this. And then one more, which is private force fade, which will be part of the timer. Okay, so let's go ahead and make a start function. And we're going to assign the rigid body, so we'll do RB equals get a component rigid body 2D, and we're also just going to give it a random rotation, just so then they don't all look the same. So we're going to do transform dot rotate 0 0 90 times random dot range 0 4, because we don't want them to rotate like 5 degrees or 20 degrees, 40 degrees, because we want to make sure that it's going to stay as it should be and as it's looking as a square. So if we use 90 from 0 to 4, then basically that's 12 o'clock, 3 o'clock, 6 o'clock and 9 o'clock that it can rotate on start. So we just give that there. Again, you don't have to use it, but it just adds a little bit of variance. And then after that, what we're going to do is we're going to do a late update. So the reason I'm doing a late update is because it generally runs after everything else is processed, or most things in the game have processed that would have been on your normal update function. but we want this to happen at the end of the frame because we're going to be adding the fade in. And we don't want it to start fading at the beginning of the frame because it's just easier to keep track of it at the end of the frame. I know I'm kind of talking a bit gibberish at the moment, but it kind of makes sense. But of course, you want to change it to an update, feel free. We're going to need to get the distance to our camera. We're going to need to make the fade, and then we're going to need to make it destroy itself. So we're going to add a float, and we're just going to call this distance to camera equals vector2.distance. We're going to do transform.position and then camera.main. So this is if you only use one camera in your scene. If you're using multiple, then you can turn this into, this is just a vector2 position. So you can add in an extra variable that you may want to set, depending on what sort of system you're doing. But if you only have one camera, then this will work absolutely fine. And then we're going to do if the distance to camera is more than the destroy distance, we're going to go ahead and destroy. And that's the game object. Else, if start fade, and we'll add in the fade just here, but underneath that we're going to add in another else statement, and we're going to do if RB does not equal null and the RB velocity dot x equals 0. So it's not moving left and right, it can be moving up and down, but it's fairly stationary. I mean, ideally if it's just moving up or down, it's either falling or jumping. So I mean, do you really want it? Let's just make the start fade true, so then it can start fading, because essentially it basically has stopped. And then underneath that we're also going to put if force fade is less than the force fade timer, then force fade plus plus, so we're just going to increase that, else start fade equals true. So we've got two different options to start our fade. So we can use the timer, or we can use if it's become still and it's not moving on the x-axis. And then once it has started faded, let's get that done. So we're just going to get the color of the sprite. So I'm going to go color, I'll just call that color. I am from the UK, so it does it does have a U. If you're watching from America and you're getting triggered right now, imagine how I feel. The coding is in American. So let's carry on and do transform dot get child, and we're gonna get 0 because it's always only gonna have one child. Dot get component sprite renderer dot color, and then we'll do color dot a minus equals the fade speed, and then we're going to apply that back to the sprite. So transform, actually we can just copy this up here, equals color, and then if it's completely faded, we want to destroy it. So we're going to do if color.a is less than equal to 0, destroy, no, not destroy distance, destroy game object. And there we are. So that's it for that script. Let's go ahead and finish up our prefabs, and then hopefully a lot more of that will make sense to you. So for our broken sprite, we can leave the sprite render as it is, but in the fade out handler, we're going to add the fade speed of 0.0125, the destroy distance of 25, So that will be from the camera. And the force fade is going to be 60, which in most cases is going to be a second if you're running 60 FPS. Although I have most of my projects capped at 60 FPS with VSync, and you probably will do too. Next is the destruction tile map. And actually, let's get building a little scene here. So I'm going to go ahead and import the tile map that you saw at the beginning. I'll also leave a description at the bottom if you wanted to grab it yourself. Okay, and there we are. So we have that just here. Now, this hasn't actually been split up yet. So I can walk you through that process if you're unsure of it. First of all, you want to head up here and make sure texture type is sprite, 2D and UI. Single sprite, you can change that to multiple. Pixels per unit. Now this one was created in 16 by 16. So make sure that you're using whatever number of the tile map that you're using. So this will actually just be like the width and height of one square rather than the whole thing. And we're also going to add tight just there and extrude edges. That's fine. Generate physics as well. Now if you're using pixel, you will have to come down to filter mode and change that to point, otherwise it's going to look very blurry, which can be frustrating. Okay, and so right, that's that for there. Let's go ahead and open the sprite editor. And there's two ways to do this. You can either literally just drag, click and drag to select a tile, just like so. Or the way that I like to do it, if you come up to slice, you can go grid by cell size and set the individual cell size. So mine's 16 by 16. And come down to the bottom and do smart. Click on save, slice, and then it will slice it into the immediate tiles that you need. Obviously this one could be one full tile. You can go in and just like edit that yourself if you need to. Okay, so let's go ahead and click apply and go to the window. We're going to go down to 2D and tile palette. I'm just going to drop this in next to my console. And it's going to ask you to make a new tile palette. So go ahead and click on that. You can leave most of this exactly the same. I never really mess around with it. Click on create and it's going to ask you to make a folder. I usually just make a folder called tiles. And there we are. So if we now drag our tile set onto here, choose our tiles folder, and there we are. So now we have our tiles ready to be used. And if you actually look in the tiles folder, you'll see each one individually as well as the original palette. So let's go to our base tile map and let's just make a little scene. So let's just go along there, and I'm just going to create a little path with a brick wall. So let's just go ahead and make that like so. Now because of what's going on, I've just realised I've made the exact mistake I was hoping you wouldn't. So I've gone ahead and added these tiles onto my base tile map. So make sure that you do change when you're changing across, and you'll notice it came up with a little pop-up there. So it does recommend changing it in prefab mode, but scene mode's absolutely fine. Just make sure you save it afterwards, otherwise you will lose the tile map you've just created. So to show this off best, let's go ahead and make a wall on the right. Of course at the beginning you've seen that this will work in multiple directions, but yeah, I could yeah, do you know what, no, let's set that up again, just and then you can see this working exactly as it should. So I'm just gonna pull a 3x3, and actually let's make that a 5x5. So let's go ahead, change to the Destructible, we'll go to scene, and I'm going to use the square tool, which if you didn't know is this one just here, and very handy because you can just drag across. Okay, so I'm going to make that a 5x5, just and then we can change how this is going to work. And again, let's make another 5x5 there, a 5x5, and another 5x5 just there. And do you know what? Let's get rid of all this. So this is our destructible tire map. And staying on the base, I am just going to add some tiles in. So let's do the gold just as a border, so then we can see what's actually happening and how they're interacting with the world. So we'll just do that like so. So as you can see, I'm literally just building this with the tile palette as you would any other game. This part itself doesn't require any configuring or any special scripts or anything like that. Let's go ahead, let's just try and make that look even-ish. I think that is actually perfect even. So let's grab our camera. I'm just going to move this to the center and zoom out so then we can actually see everything that's going on. And then I'm going to make some spawn points, but actually let's not make some spawn points. Let's actually spawn them in straight away, just so then you can see what happens. So now that we've got our tile map ready, let's just continue getting these set up. So we have our tile splitter temp. So the tile sprite is going to be the tile that is set when it's spawned in. Our physics material is the broken sprite. The prefab is going to be our broken sprite. So let's just make sure that's locked. And whenever you're dragging in a prefab, make sure you're dragging it in from your project section, not the hierarchy. Otherwise it will be that single instance rather than the actual prefab. Just go ahead and drag the broken sprite into the prefab. And then we also want the parent sprite. Destruction parent just there. And then the sprite masks. So let me just switch over and grab the files for this, and then I can explain how it's going to work. Okay, so I've just added a new folder and it imported a mask. So you might be wondering how this is going to work, and if I can zoom in, so you'll see this mask just here kind of has break lines between it, and then I've split this into individual sprites. So what this will do, if we just create a quick sprite so you can see, so if I get a square here and add a sprite mask, let's say we'll choose this one and add that to our sprite mask. And actually let's just adjust these to 500, the full rect, just like so. So then it fits within our cube square. So right now the sprite is displaying just as a square, as a normal square. But if we now go to the mask interaction and change that to visible outside a mask, it cuts out that shape. However, if we change it to visible inside mask, it turns into that shape. So using this, we can then break apart a single sprite. So let's get rid of that square, head into our tile splitter temp, and we're just going to click on all of these, which I will be making available to you below, although you can make your own. It's very simple. You just need to be able to break a shape up basically into separate masks, and then we can head to our tile splitter temp and add these into the sprite masks, just like so. And because we've set this up to work on the amount of number of these, that's all you have to do. You don't have to change any code if you decide to break it up into more pieces. You just have to put the masks into this, into the script here, and that's it. Okay, so we have our tile splitter temp, and I believe that's all we need. Let's just add a force speed. So I'm going to set that to 5, which will be the same as how you saw it in the intro. Let's go to our impact point. Now nothing else needs to be changed here except from our tile splitter. So let's go into our prefabs folder and grab that. And let's just lock that. That is right here. So the tile splitter temp. Let's go ahead and apply the overrides to all of these just to make sure they're actually being applied to our prefabs. And it would help if I didn't lock myself into one UI. Okay, and now to apply the mask, let's add a new sprite to the broken sprite. So we're going to go down to 2D, sprites, and square. And we're just going to name this as sprite. Or let's call this the visual sprite. Because what we're going to do is we're going to base the collision off of the parent object. And then we're going to use this sprite object to actually display it after it's been masked. So we're going to add that mask in here. So the sprite mask. We're going to change the mask interaction to visible inside mask. And we're also going to change the alpha cutoff to 1. And that is it for that. So let's go back to the broken sprite. Apply all. The impact point is all there. The destruction handler is okay. Okay, so let's just remove some of these from our scene because we don't need the broken sprite. We don't need the destruction parent. And we don't need the tile splitter temp. However, we do need the impact point. So let's see how this works. So if I move this, so we have a 5x5 grid. Let's move that over to here. If we keep it as 3-3 using the code that we have already scripted, what it's going to do is it's going to find the closest tile in a direction. So it's going to test up, right, down and left. Because there's only one here, it's then going to set this as a start point. And then we're going to fan out because our forward direction is going to the right. But we need to fan out to the left and to the right of that direction. And then once we get that, we will then go in through depth, which will be our Y. So the X is the fanning out to the sides, and the Y is the depth that is actually going to go through the wall. So let's go ahead and test this out. But before we do, it's worth noting collision can take an impact on performance. Now, in my tile masks, I only have a few. But originally, I did start with about 20 different pieces. I've had to reduce it down to this number because when you're spawning them all in, it does take a heavy toll. So I do recommend if you do decide to do your own mask, then try to keep it low. But another way that can help with that is if you go to Edit, Project Settings, in Physics 2D and scroll down, you can actually change how the collision works based on the layers. So let's go ahead and do that now. If I go to the layer on our impact point, or actually on the base tile map, I'm going to add a layer, and I'm going to call this base tile. Now we do want the pieces to actually interact with everything else. So let's go ahead and just add that to our grid. But then the pieces that are going to split off, we want to be able to interact with that and control that. So let's go to prefab, broken sprite, and layer again. And let's just call this broken tile. Back into our prefab, broken sprite, and set that here. Yes, change children. And if we go back into edit, project settings, you'll see that we now actually have these here. So we have broken tile and base tile. So what I want is for the broken tiles to interact with the base tile, but not each other. This in itself will bring performance up massively. And I'll show you the difference in just a second. So let's go ahead. We've got our impact point just here. I'm also going to go ahead and override the destruction tile map. and let's hit play and see what happens. And as we can see there, the masks look like they've taken over the colour. So let's find out why. Let's just make sure that these are all 0, 0. And that is because we haven't told it to get the sprite. So that's my bad. If we just come into destruction source handler under line 53, we're just going to add a couple of lines here. So we're going to go handler dot tile sprite equals destructible tile map dot get sprite position, and handler dot force position equals transform dot position. I'm not sure why I decided not to add that in earlier. I think we had to get the initial position, possibly. But there we go. So if we head back into Unity, we restart this, and let's actually add some collision to our base tile map and to our Destructible tile map. So let's go down here to collider, tile map, and now you can use this as squares, but the best way to do it is click on use by composite. We can add the composite collider, which is just here, and what that will do is instead of individual colliders, it will turn it into one singular. Now this is an outline, but you can change it to polygons, which genuinely just runs faster. Go ahead and hit apply on the override, and we'll do the same thing to the base tile. So we'll get a tile map, use composite, and we'll add the polygon, no, not the polygon collider, the composite collider, and change that to polygons. Okay, and there we are. So we have our base tile map with collision, we have our destructible tile map, and our impact point, and now hopefully this should be working a lot better. You'll also see that we are setting the radius up by 3 by 3. Oh, let's just adjust that rigid body. So if we go into the base tile map, because we're using the composite, it's going to use a rigid body. So let's just set that to static. And the same on the destructible tile map. You'll also notice that we have 3 in our impact point, but it seems to be going 3 up. So let's just fix that quickly. If we head over into our destruction visual, or destruction source, and head down to, I realise I've made a mistake in that this is a radius, and that we want the, not circumference, but width. So let's just change that. So the into an int here, so int width equals impact radius, and we'll change that to .x, and then we'll make the impact radius equal the width divided by 2. Actually, the width minus 1 and then divided by 2. And then we'll just go ahead and change that in here. So we'll just change the .x, and we can actually just leave that exactly as it is. But doing this conversion will just mean that it will be exactly the same width as intended from the center, rather than 3 either side. Now the actual sprites were fading into black, and I've realized I've made a mistake, because if you go into the prefab and open a broken sprite, what you actually want to do is make sure that that sprite is transparent, because you don't want to see it, but it's going to be on top, and the only reason you're using it is for the polygon collider. So let's go ahead and do that. And let's test this again. And there we have it. We have a 3x3 grid that's broken off and faded and actually interacted with the world. So let's go ahead and try and change that. So if we change that to say, to go 5 in, and we'll see that that breaks straight across the strip. And if we move this impact point to the top and zoom out, we'll see that it's still going to go 5 in to the wall and 3 wide across it. Or maybe not. Of course, so when I copied and pasted this last time, the get direction from impact, I forgot to add on the Y at the end of direction. So if you just add swap the X for the Y at the end, I'm hoping you possibly done that on your own anyway. Maybe you realised my mistake before me. In that case, thumbs up, good on you. Okay, and again, in destruction source handler line 158, make sure you change this direction to direction.y underneath the X. Let's look back and see if that works. Huzzah! And there we are. So that looks like, ideally, that should be moving over to the left. So let's just have a little look in here. So this is adjust the start position. So I'm just going to add in a -1 here, just to see if that fixes it. And there we are. So as you can see, they've all fallen down into the hole and disappeared. Now you can see that it is a bit intensive when you're working like that, and of course it does depend on the game that you're using, but when you do go to build it, it does run a lot smoother. Let's just also move this down to the bottom just to make sure that it's still going to be working. Okay, so that is interesting. Let's go into the code and just adjust that. So if the Y is more than 0, let's add in another offset. So let's just add an X offset. And if the direction Y is more than 0, so if it's above it, we're gonna set that X offset to 1, or -1 even. X offset equals -1, else X offset equals 0. X offset equals 0, and let's just add that in there, and we'll change that into a plus symbol. Let's head back into Unity and try that again. Huzzah! And there we are. So that's happening in the middle. Now, as I say, it can get a bit intensive. So if you can attempt to make these tile masks as large as possible, or as little in quantity, it's always much better just for the actual colliders working on their own. And we will also go in and change some of that. So if we go to prefab, broken sprite, go to the rigid body, we already have interpolate on. You can also, if you would like, to freeze the rotation, but as I said earlier, right now they're colliding with everything. So if we go into edit, project settings, and stop them from colliding with each other, they'll still collide with the base tiles, just not each other. You'll see the performance is about to increase dramatically. And as you can see there, very little lag, a tiny lag spike at the beginning, but it's expected to happen in the expector. If we was to go to file, build settings, just create a build folder to test this out. we should see the initial lag spike should reduce dramatically, if at all, not even be there. But again, you've also got to remember that we are doing this from the start of the game, so when you do initiate it, or say that you do break the wall, then it's going to be a lot easier for the computer to pick that up while you're playing the game versus as it's starting. So let's take a look here. And as you can see there was almost no lag whatsoever. Let's just Alt F4 that and double check if we move this to the left side. Is it also going to work again? Okay, so again we just need to make a slight change, just like we did with the Y. So we're going to add in this X offset again, just in here, and I'm actually just going to copy this over, and we're going to make sure we change that to X. So the X offset, although this is the Y offset this time, so let's just make that apparent and add that in here without pressing the wrong buttons, just like so. We'll pop back out and test it. Oh, and that's still doing it, so let's just double check why that is. So we're going to go, so if it's on the right, there we go, look, see, I didn't even read it, I just copied it. So if we go to the right, it's 0. If we're going to the left, we want to do -1. There we go, and let's just test that again. Perfect. So now if we want to add more impact, we can head into the tile splitter temp and we can just change the force speed. So let's say we want to, actually let's keep that as 5 and let's go to the broken sprite, into the rigid body. The mass is already 10 apparently. Okay, so let's go back into here. So in the tile splitter temp, you can change the amount of force that's going to happen just in the force speeds. Let's set that to say 15, and we should see them all kind of being pushed out or not. So why have we not got that in here? And actually let's lower the mass because 10 is quite high. So if we keep that on 15 now, we should see a good difference. Or not. Maybe let's change that to 80. Okay, so that doesn't seem to be working. Let's just add a little debug in here. Debug.log to make sure that we are getting a direction. So force direction, just like so. Okay, so it seems that this part of the code isn't even running. Apply force timer. Force time equals 10, so let's maybe put that down to 2. And of course, that would be why, because I've added a timer with only a single function. So let's actually put that into an update, just like so, and we will add a private bool, force applied, and So I'm not sure how I've done this before. Let's scrap the timer because I don't think it's going to work. If you would like to add that in, of course you can make it work for you, but I don't think it's entirely necessary. I know I did say about it at the beginning, but right now having that timer seems to be breaking it completely, and I haven't actually used the timer before, so there we go. So as you can see, it is actually being shot out. So let's just go into here, we'll change the force to 10 just to slow it down a little bit, and as we can see, it's like something has actually hit the wall and broken through. So let's go ahead and just duplicate these, so then we can see it working in all 3 directions, or all 4 directions, sorry, just like so. Because these impact points, you can just spawn it at that position and it will act dependent on where the tiles are relative to its position. As you can see, it works in all 4 directions. And then if we also go back and we could change this one to say 1, just keep in mind this x-axis will always have to be an uneven number because you have the center point and then it fans out. So let's change that to 1 and maybe the other one to 6. Let's change this one to 5 and 3. We'll change this one to 3 and 3, and we'll see just here that they all interact dynamically on their own because they're able to find the tiles based on their radius. And it would seem that the other side didn't even hit. So why was that? Let's have a look at that one. This is 1 and 6. So it looks like it can't be less than 3. Let's figure out why that is. If we go into the source handler and we look at the impact radius, we'll see that we are dividing it here. So let's just change that to be if impact radius is more than 1, then we will convert it. That is the dot x. Then we will convert it, and then hopefully if we go back in, change that back to 1, we should see it working in a single line. Okay, and it hasn't. So let's see why that is. So if it's more than 1, let's have a look. I believe it might actually be an issue here. So let's keep that there, and then we'll do if it's less than or equal to 1, we'll get a single starting point. So if we just copy that there, then we can actually just make, or actually we can just add our starting point. There we go. So if I just go in here, change the position 1 to starting point, get rid of those, we'll add in the extra brackets and fix that there. We'll also move that into there, and then we'll change this to else and add this for statement into that bracket. So this one up here is if it's just a single line, and this one is if it's gonna fan out. And then we'll do the same thing just down here. So if impact radius, and actually we can copy this word for word, and then just add in the extra bracket at the bottom. Okay, so let's head back into the editor. We'll give that a try. And there we go, so it's gone in a singular line. Let's just make sure. So some of these were different. So if impact radius.x is more than 1, we can minus the 1 and divide by 2. So actually let's make that more than 2 instead of more than 1. And if impact radius.x is less than or equal to 1, so let's actually change that to less than 2. Else we'll do this, because we'll just want the initial starting tile, and then this will be worked off the tiles. Or actually let's change this to if it's more than 1, and we'll swap these around, so just like so, and we can actually just change that into a single else, so that actually cleans it up a little bit. And we'll do the same thing up here. So if that's more than 1, we'll do our for statement. If it's not, we're gonna just set it as the starting point, as a singular starting point. Okay, so let's go back into here. So we have 1 and 6. 3 and 5, 5 and 3, and 3 by 3. So only this one should work as a single. Okay, so again, they are still working like that. So why is that? If impact radius.x is more than 1, we will split it. Or actually we can change this down here to width and move that just there. There we go. So if we actually just clean that code up a bit at the top, then we can change this to width. So if width is more than 1, we'll do that. Otherwise we'll do a single line, and we'll also change that just down here for the left and right, and ideally that should fix it completely. Oh yeah, of course we can get rid of the .x on there as well, because the width is the total number rather than it being split. So let's see how that works. Okay, and there we are. That's actually working properly now. So let's just change a couple more. So let's change that to like 5. This one to 1. Just to make sure that it's not just a single time that it's going to work. Okay, and there we have it. So that is a dynamic tile map destruction system. Yeah, I mean, I'm proud I even managed to get this far, and I'm hoping it's actually to help you a lot more than the help that was offered for me. I mean, you try and have a look online, and there's just barely any documentation. It's just not really something that I think a lot of people have looked into, or been willing to share. I mean, there doesn't seem to be any YouTube videos on it, any just Stack Overflow talks about it. So yeah, so I thought it'd be worth mentioning here, and yeah, I hope you guys have enjoyed. If you want to see this being used as an example in a game, let me know in the comments below, and I'll get another video uploaded on how to implement that. But yeah, I hope you guys have enjoyed. As I've said, once you have this all set up, all you have to do is just put an impact point next to the wall, so however it is that your weapons or the way that you want to go around it is being done, you can just put it next to the wall and it will just explode. So you can even turn it into a bomb or anything. So I hope you guys have fun with that. I hope it's been really useful for you. As I've said, it's just been a minefield for me trying to figure this out. And yeah, so I hope you've enjoyed this so far. And if there's anything else that maybe you're getting stuck on, or you want to see more content or just more tutorials, let me know in the comments below. And if you feel like leaving a thumbs up or subscribing, much appreciated. And yeah, hopefully you'll be seeing me more often. My name's Jordan, this has been Destructible Walls, and I'll see you in the next one. Peace.